Joining us now is Dr. Bryan Copple, Associate Professor at Michigan State University, and Dr. Christian Trautwein, who is Director and Professor of Medicine at Aachen University Hospital. Thank you so much for joining us.
Hello.
Your session is on fibrosis, the basic mechanisms and novel therapeutics. Can you tell us a little bit about that?
Of course, I'm happy to do so. So the nice thing is that more and more we get into detail what's going on in fibrosis. And I think one cell which is very important is the hepatic stellate cells, also called HSCs. And in the recent years, it's become obvious that this cell is very important for liver fibrosis progression. First of all, the stellate cells is transformed into a fibroblast. And this fibroblast, over time, produces collagen, and through this, the scarring of the liver is induced. And this progresses over time. On the other hand, we know meanwhile that these fibroblasts can again reverse into the quiescent stellate cells. And therefore right now we are aiming at three different mechanisms which are important for liver fibrosis. First of all, the transmigration from the quiescent stellate cell into fibroblast, and the progression of the fibroblast to collagen producing cells, and the linkage of collagen to make the scar firm. And then in the end, the possibility of the resolution of the stellate cells going back to the quiescent state. So this means we have three different possibilities now to force to reduce fibrosis. And I think this will be a big field for the future and will be very important for us.
Talk a little bit about the leading causes or mechanisms of fibrosis.
Well, Dr. Trautwein touched on some of those, but many of the leading causes of fibrosis would be chronic alcohol consumption or anything that would chronically damage the liver, such as hepatitis virus. There's also genetic disorders that can lead to liver fibrosis and also autoimmune diseases. And like Dr. Trautwein said, one of the main players in liver fibrosis are the hepatic stellate cells, which become activated during this chronic liver damage, and they begin to secrete collagen, which leads to the scar formation. In some types of fibrosis, however, especially associated with biliary obstruction or damage to the bile ducts, another cell type that can contribute to that are the peribiliary fibroblasts, which can become activated and deposit collagen within periportal regions of liver. And this is another area that I think is becoming more actively investigated.
One of the early abstracts during the liver meeting had to talk about the targeting of LOX-L2, and that's a rather interesting therapeutic.
It's an interesting new topic because, as I just tried to explain you, after the stellate cells are fibroblasts, the collagen is produced, and then the collagen is linked to each other to be firm. And this step is obviously mediated by LOX-L2. And now the mechanism how LOX-L2 inhibition works is to break down this firm interaction of the fibers. And I think it's a very interesting concept, it's a new concept. And obviously, as shown in this session, it worked. So I think it's a new concept, and I think at the end we'll have different concepts together which will work against fibrosis.
What are the takeaways you hope people will get from this session?
Well, I think the main takeaway is that research in liver fibrosis is progressing, and that there are new targets of therapy that are being identified all the time, as we saw in this session.
And I actually think that industry is getting more and more interested in it. And last year, hepatitis C was the topic. And meanwhile, we have much better sort of mechanism to measure fibrosis, to understand fibrosis, to measure regression of fibrosis. I think therefore in the future, fibrosis will be one of the fields by industry taken up and will be a very major, important aspect of hepatology.
Sounds terrific, and sounds like it's jam-packed with information this session. So thank you so much for joining us.
Thank you.
Thank you very much. Pleasure.